Okay, here's video number 2. This is for problem number 2, the one we just did 3 parts of. I've done all 5 parts. I don't have an answer key for this, so I didn't feel that confident about when I did the first one, but I found an answer key, and so I checked it, and all the answers were good, and so now but I couldn't find an answer key for this one. So I felt okay about the problems. One of them one of the 3 you had to do, I was really uncertain about for a while. But then I had an epiphany. But I don't know if these answers are correct. So we'll have to see. So here we go. Whoops, sorry. I have to switch it to the camera. There we go, to the camera. Okay, question number 1. This was a pretty straightforward one, I thought. I mean, it's algebraically a little bit much, but it's nothing horrible. And it was just, they told you g of x is equal to this, and find g prime of 2 is what you're supposed to find. And I just substituted in, for x, I substituted in, oh, wait, hold on a second. I'm already concerned. Wait, I have to take a look at this. H of 2x is you plug 2x in for the 2x. Ooh, yeah, I see a little bit of a mistake here right now. I haven't checked my work other than doing the problems. So yeah, this was not right? Because h of x, I'll do it live. H of x is 2x minus 5. So h of 2x, you plug the 2x in for the x. I did kind of the reverse of those things. And so 2x goes in there, so it should be 4x minus 5. Yes, and so this should be 5. Let's write that clearly. And so this should be 5. And you're finding g prime of 2, so that's 8. 8 minus 5, which is 3. And so that's 3. That looks like the only place it affected things. So we're good. I lost a point there. Anyway, so there's slight error there, but you have f, and so I used the fact that they told you what the function h was, and I just put it in. You could just do it with h prime and then work it in later. Either way is fine. And then it was just a product rule with some chain, and then plugging in 2 at the end. And again, I left it in my form. I did, I don't know about you, but I did, forget for a moment that f prime was what we were looking at. So I was thinking we were looking at f. And so f prime would be the slope of the graph that they showed us. I think I still have it open. No, I don't, but I can. I have it right up there. There we go. And so, but then I spotted it and fixed that one. Anyway, so that was A. A was pretty straightforward. Question B, back to the answer key. There we go. So question B was the one that really stumped me for a little bit. So they said what the integral from 2 to 4 of f prime of 2x minus 5 was. And when I was thinking about it, I was thinking f prime of x, not f prime of 2x minus 5. And so when I was looking at the graph, I was thinking, well, why are they telling us what this area is? Isn't this something we could just calculate? Because between 2 and 4, that's just the area between here and here. And I was a little stumped on that for a little bit. You can see my kind of chaotic here. So my first thought was then I looked at what the question was asking. Ooh, I want that for a second longer. It says, find f of negative 1. So they're giving you this area, and they're saying find f of negative 1. That seemed kind of strange to me. But I was like, well, let's go with the integration, the accumulation formula. So f of negative 1, the one value we have, switch back, sorry, is we gave us f of 3, so we'll start with that, and then plus, and then we integrate f prime to find out what the value is at negative 1. This is the, where I am plus how much I change, what my accumulation is. So I just wrote that down. And then I realized, wait a minute, the bounds here are 3 to negative 1, but they gave me the bounds from 2 to 4. That seems kind of confusing, and I realized what we needed was a u substitution, so that when we do a u substitution, we're going to change the bounds. And so then I was like, that's me, having a moment of epiphany. So I said u is equal to 2x minus 5 and then substituted. And then I was a little confused because I was trying to do the u substitution on this, but really I need to do the u substitution to transform this because this has the 2x minus 5 in. So I said, all right, so this is what they gave me, and now I'm going to do the u substitution that they gave me. So this becomes u, and du is 2dx, so 1/2 ends up going out in front because dx is 1/2 du. Got it. And now I've got my bounds issue, and so I said, well, what about when x is equal to 2? Because that's what I'm starting with, x equal to 2. And when you substitute x equals 2 into this, you find out u is -1. And when x is 4, then you find out that u is equal to 3. And so this is taking this one and transforming it with the u substitution, it becomes this. And now I look at what I'm trying to find. I wanted the integral from 3 to -1 of f prime of, and remember, it doesn't matter what letters they are, f prime of t dt or f prime of x dx or whatever. I don't care what those letters are, because that's just saying this function with this variable, and the variable name can change. So then when I look at this, I go, oh, wait a minute, I've got the integral from -1 to 3. I want the integral from 3 to -1. That's easy. So I first multiply the 2 over, and then I flip the integral to make it opposite. So that means that this integral right here is just -44/3, and f of -1 is 7. Really interesting problem. I thought very challenging to unpack. Once you spotted this idea of these bounds are wrong, and I want these bounds, but I'm starting with this variable in here, and I want this one, then the u substitution idea, and after that, the u substitution idea, it becomes pretty easy. This would be a really challenging problem on any AP. I thought this was, like the hardest one to just see and to recognize from earlier problems. Part C. Part C, what was the question again? I haven't looked at this for a little bit. Part C was, given that, find that thing. All right. So they gave me that. I need to find what this one is. And I just decided, because I'm going, because h of x is 2x minus 5, I just substituted that in. Sorry, there's another weird substitution happening later. So I put that in there for the f double prime. I'm trying to find out what this is, given that this is true. And it looked just like a parts problem. And so I said u is 2x minus 5, because then when the du, I can make that part go away. And dv is this, so v is the antiderivative. And so it's uv minus the integral of v du. I'm just taking a look at it right now because, again, I haven't been able to check my answers, and so I'm a little apprehensive. And then we want to evaluate this from -1 to 5. So first I plugged in 5, so that's 5 times f prime of 5. Then I plugged in -1, and I got that. That looks pretty good. And then minus, and then this, and the antiderivative of f prime is just f. Oh, no, I'm sorry. No, that's where the given comes in. I had to do the integral from -1 to 5 of this thing. That's right. Here we go, down here. So the integral from -1 to 5 of this thing, well, that's the integral from -1 to 1 of this thing, plus the integral from 1 to 5 of this thing. And this thing is 40/3. They gave me that up above. And then this thing, I just counted boxes from the graph. Hope I did it right. I got 8, just counting area, to find the integral from 1 to 5 of f prime. That's just the area under the curve up above. And so I just wrote that and then left the answer as is. I figured out what f prime of -1 was because they gave us that on the picture, and f prime of 5, I could see that from the picture too, right? F prime of 5. Yep, that was -2. This one, a close second to the previous one. Very challenging. I hope you saw the parts idea, and depending on how far you implemented it, you'd get partial credit. Okay, part D and E, you didn't have to do these, but I wanted to show you them. Doing good on time. It was you had to integrate this thing, and from 1 to 2. From 1 to 2, sorry, I didn't write that down. And so I just substituted f prime of x being 2x minus 8, because this is the key idea, was because it's linear between these values and I'm integrating it between 1 and 2, that means I can just use the formula for this line, which is 2x minus 8. So it became a partial fractions problem. You could pause it right now, and try to do the partial fractions problem yourself if you didn't try it before. But if you just want to watch, then I did this, usual partial fraction stuff, And so I thought about making x 2.5, and I was like, fractions. And so I just started with x being 4. And so that cancels this out. And so plug 4 in there. That's 8 minus 5. 3a equals 24. Plugging in 4 right there also. Yeah, I'm checking my work as I go here. So a is equal to 8. That looks pretty good. And then I was going to have to plug 2.5 in to figure out the other one. And then I thought, well, hold a second. If a is 8, I can see that negative 40 plus, and then b times negative 8 has to give me 0 because the numbers have to go away. Or the way I actually did it was with the x's. I saw it. So a is 8. So that's 16x right there. And I need b to be the right number to get me down to 6x. And so I just spotted that b was negative 5. So you get this integral. You have to do the antiderivative. Remember that you have to have the chain rule taken into account. So it's not the antiderivative of, I'm going to write this down below. The integral antiderivative of 1 over 2x minus 8 dx is not natural log of 2x minus 8 because of chain rule issues. If I took the derivative of this, I'd get an extra 2. So when I do this, I need to have a 2 sitting out here in order to be the derivative of the inside and a 1/2 on the outside. So as a result, this antiderivative becomes 4 times 2x minus 8. Also, you needed the absolute value on this one. I noticed that. And then this one, same idea. Because when you plug the numbers in, you get negative numbers, but it's absolute value when you do the antiderivative of 1 over x. Technically, it's natural log of absolute value of x. And so you plug it in. I got this, and then I just stopped. Same thing. I hope I did that right. But again, I did not do anything more than that. Actually, I could plug into a computer, and a computer could work this out for us. But I'm going to pass, and I'll wait until the guy emails me back the answer key. Not yet. Okay. Last one. What time are we at? Ooh, 12:17. Got to hurry up. So this one was a third degree Taylor polynomial for k, and k prime is equal to this. And they give you a little more information. So here we go. So I said third degree polynomial for k centered at 1. So there's the Taylor series formula. With 1, I totally just threw, when I talked about it on the other video about what if it's not centered at 0, and I just threw in the number 1. That was totally random. I hadn't done this problem yet, so that was kind of lucky. And so that's the third degree Taylor polynomial centered at 1 for k. And so they told you what k of 1 was. So now you need k prime of 1 and k double prime of 1 and k triple prime of 1. What they said was that k prime of x is f of x plus 2. So k prime of 1 is f of 1 plus 2, so that's f of 3. And you can get that from one second. Oh, they told you that. I was like, why did I get that? Oh, I remember. It took a long time for my other video to upload, so I've forgotten what the problems were, what my answers were. So f of 3, they told you in the previous in the above problem that f of 3 was 7. So we got that. That was the anchor point. And then k double prime of 1 is going to be derivative, so f prime of x plus 2, so f prime of 3. And that's just the y value up above. And k triple prime of 1 is the second derivative of f, which is... Hold on a second. Did I do it again? I did it again. Man, this is driving me crazy. So I got to change my answers here. So f prime of 3 is equal to 2. Got to watch out for that. Which thing are you doing? And f double prime of 3 is negative 2. So there we go. So I forgot that graph above was f prime, not f. And so f prime of 3 was the y value up above, and f double prime of 3 was the slope of the graph above. And it was linear at that point, so the slope is negative 2. Okay, whoop, almost out. So this number should be positive 2, and this number should be negative 2. Again, I think I lose a point, maybe 2 on that one. Maybe working fast and not checking your work, that'll happen. So that's the those are the answers. I'm out of time.